How many programs are running on your computer right now? Let's take a look. If you push Command Tab on an OS 10 operating system, you can see a list or icons of the programs that are currently running. So let's start at the beginning here. It says 1, 2, 3, 4, 5, 6, 7. I got 7 programs that are currently running on my computer. Now, a normal user is just going to talk about, I've got 7 applications running, or I've got 7 programs running. But if we take a deeper look, and as computer scientists, you do take deeper looks, we actually have 374 separate processes running on our computers. Your computer is responsible for managing and juggling resources. A resource can be a bunch of different things. Traditionally, a resource is CPU and primary memory. And we all know that inside the CPU there's all kinds of cool stuff, okay? But we're also concerned with networks. We're concerned with bandwidth. We're concerned with screen resolution. We're concerned with disk storage. There's a whole host of separate things that we're concerned with when we talk about resource management. You need to be able to understand what resources are available. And in a kind of a neat way, you need to be able to describe what happens if you try to do something on a computer without enough resources. Let's check out this hot game. This is a really cool game. League of Legends. I've never played it before, but look at that. That's cool. What would happen if I wanted to run this game on this computer? Oops, I missed. On this computer. So it might not work, but why? Why wouldn't this work? What exactly would prevent League of Legends from running on this, let's face it, this pretty awesome computer? Why would that happen? So you need to be able to understand that in resource management and talk about what might happen if you don't have enough resources to run something. Traditionally, when we talk about resource management, we're talking about memory, peripherals, and hardware interfaces. A peripheral is something that's connected to the computer, like a mouse or a keyboard. When you move the mouse, as I'm moving it right now, you can see that the position of the mouse is changing as I move my finger on the trackpad. Your operating system needs to sort of stop what it's doing, catch that signal that I'm sending via the trackpad, and update the position of the mouse and draw the mouse on the screen. This all happens in milliseconds. It's pretty cool. What gets really interesting with resource management is when we start talking about the memory address, the instruction, and the CPU. So if we take another quick look at this diagram here, you can see this is our primary memory over here, and this is our CPU. It's sort of, let me try to see if this works. Yeah, there we go. Okay, so now it sort of looks a little bit better. So here's the primary memory, and here's the CPU over here, right? So what strategies can your operating system use if you've got how many was it again? 373 running processes, and all of them need to have CPU time, and all of them need to have memory. How is it that your operating system does this? This is the essence of resource management. We'll also talk about hiding complexity and why does it look like I only am running 8 programs here. Okay, why am I only running 8 programs when in reality I'm actually running 374? And if I looked at all processes, I might be running 376 or even more. There might be even more processes that are running. Okay, there's a ton of them. So your computer hides, your operating system hides all this complexity. Normal users don't see it. Why? This is the essence of resource management. So as you think about resource management, you should get really curious about how your computer allows a lot of different things to happen when it doesn't have enough memory and CPU capacity to do all of them at one time. Okay? It's super, super interesting topic.